Hello everyone, this is Shivani Srivastava and I am here with a very interesting topic which is work and energy. We are going to discuss about the work here and you will be wondered by knowing what is work. As by sitting at your place and by seeing my video, you are doing your work, you are studying continuously by sitting at your place. But a physicist will say, you're not doing any work. I'm sitting here and I'm teaching you continuously by sitting at place, by using my pen tab, by using my stylus, but I'm not moving anywhere. So a physicist will say, I'm not doing any work. So what is work actually? So according to physics, there should be a displacement in the direction of applied force. Then only a physicist will say, yes, now you are doing any work. Okay, got it? So according to physics, what is work? Work is the product of force and displacement in the direction of applied force. So what work is? Work is force into displacement in the direction of force. Okay, so what work is? Force into displacement. Means if there is no displacement, or we can say displacement is equal to 0, then the work done will be is equal to force into 0 means 0. Okay, and if you're not applying any force, like we can get from Newton's first law, right? What was Newton's first law? Newton's first law was, if there is any force, then only the object will move, right? Conclusion was that only. Like what? If any object is at rest, then it will remain at rest. If any object is in motion, then it will move continuously until or unless you are not applying any force from the external direction. Right? So force is very important. So here also to do work, force is very important. Now we are discussing force and displacement in the direction of force. But we are not saying anything about the direction of force, right? So the direction of force is also very important. So if we'll say the direction of force, about anything about direction of force, so we do have a different formula, which is force into displacement into cos theta. What cos is there? Because you are in class 9th, you don't know the trigonometry factors, I think so. So here, if you don't know about trigonometry factors, so we do have 6 trigonometry factors: sine, cos, tan, cosec, sec, cot. Okay, but here we will go with cos only. So we do have different values of cos, okay, which depends on the angle applied by us. Means you are going anywhere to your native or to your grandmother house, and you do have a trolley bag, right? So how you will hold that trolley bag? You will hold that trolley bag like this, and the trolley bag will move in this direction. Means there is an angle between trolley and the direction of trolley bag. Okay, means how it will work? It will work like this approximately. Here you are applying the force and the trolley bag is moving in the forward direction. So this is the direction of displacement. So here is an angle between force and displacement, which we can say theta. Theta is a Greek word. We'll use many Greek words like this. Theta, beta, many are there. So now, please note down few values of cos theta. Okay. So if theta is equal to 0 degree, then value of cos will be 1. These are some fixed values. You need to learn. More explanation we will get in grade 10th. Now, 45 degree, this is 1 by root 2. 60 degree, this is what? 1 by 2. 90 degree, cos 90 degree is what it will be? 0. That only we will discuss more. I'll explain you all. Don't worry about it. Cos 180 degree, this is -1. Please note down all these values. And For a few times, you need to remember. Now, this is our formula. W is equal to F into D cos theta. And now we are moving. What is the unit of work? What will be the unit of work? Unit of work will be joule. Okay, unit of work is joule. Now, is it a scalar or vector quantity? Work is actually a scalar quantity. Okay, now we'll discuss how these angles will justify our formula. So, if we are applying a force in the same direction of the motion, means force applied and displacement both are parallel to each other. So if two things are parallel to each other, then what will be the angle between them? Obviously, the angle will be 0 degree, means theta is equal to 0 degree. So from our definition, we do have work is equal to force into displacement into cos theta. And here we'll put the value of theta, which is 0 degree. So force into displacement into cos 0 degree and displacement into 1. This is the highest value of work done. Okay. So here one short question also becomes like when the work will be highest. So when you are applying force in the direction of the motion, okay, then only the work done will be highest. Means if there is a 0 degree angle between force and displacement, then the work done will be highest. Okay. And when our displacement is in the perpendicular direction of applied force, okay, so means here the angle is 90 degree. Theta is equal to 90 degree. So now if we'll put the value in this same formula, F into D cos theta. So here theta is equal to 90 degree. So we can say cos F into D 90 degree. Okay. So cos 90 degree, we have discussed before only. This is what? 0. So cos 90 degree will be 0. So our work done will be what? F into D into 0. It will be 0 degree. Right? So means there is not any work. You got it? From here only we have started our lesson. I said now you'll be wonder by knowing what is work and what not. Okay. So if there is no displacement and if there is an angle 90 degree, means your force is perpendicular to the direction of the motion, then here will not be any work. According to physicists only, if you will study by sitting at your flowers, then your mama will say you are very good and you are doing work. But according to physicists, there is not any kind of work. Now we have one more quiz. In the same case, like you are applying force in the forward direction, object is also moving in the forward direction. So in the same scenario, someone can ask to you what work is done by frictional force. Okay. What is the work done by frictional force? And what will you say? See, displacement is in this direction and force applied by friction is in this direction, means it is opposite direction of the displacement, right? Means what is the angle? So angle is 180 degree. Okay, the angle is 180 degree. Now, according to the same formula, F into D cos theta, I'll write these many times the formula. The formula will be in your mind only. Okay, so work done will be what? F into D cos 180 degree. And we have discussed, please go backward and see in this, like cos 180 degree is what? -1. So work done will be F into D into -1. Means work will be in negative form. Okay. So work done by the frictional force is opposite to the direction of the motion. That's why it is negative work done. Okay. Same as we have discussed in before chapter, acceleration, negative acceleration, right? We can relate a little it with there also. Okay, now we'll move our next topic. Now we'll solve one numerical related to this topic. See here, a force of 10 Newton causes a displacement of 2 meter in a body, okay, in its own direction. Calculate the work done by the force. So, what they are asking? Work done by the force. What they have given? They have given force is equal to 10 Newton. Displacement is equal to 2 meter. In the so what they are asking? Work done in a body in its own direction. Direction also they have told. So we know the formula. Work is equal to F into D because they have given in its own direction. No need of cos theta. So W is equal to 10 into 2. So what it is? 10 into 2, 20. And what is the unit of work? It is joule. So work will be 20 joule. Okay, got it? Now we'll solve one more numerical. Now see, here in this question, what they are saying? They are saying a force of 10 Newton. Force they have given 10 Newton acting on a body at an angle of 60 degree. Means they have given angle. So theta is equal to 60 degree. With the horizontal direction displaced the body through a distance of 2 meter. Means they have given distance also. It is 2 meter. And what we need to find out? Distance of 2 meter along the surface of a floor, calculate the work done. So work we need to find out. Now we have to apply the formula. W is equal to F into D into cos theta. Very simple, right? They have given angle. That's why we are using this theta formula. So W is equal to force into displacement into cos 60 degree. We'll keep all the values given. W is equal to 10 into 2 into cos 60 degree. What is the value of cos 60 degree? 1 by 2. You can check the table. This 2 and this 2 both has cos. Now W will be 10 joule. So what work done is here? 10 joule. Very simple. I hope you got this formula and you got this definition about work done. Now here, we will discuss according to some examples. Is there work or not? So Suma is swimming in a pond. If someone is swimming in the pond, then they will move in the forward direction, right? The river is like this. And if someone is swimming on it, then they will move in the forward direction. So force applied by the hands is there and legs also. I don't know swimming, but I know the process only. And the person is moving in the forward direction. It means there is displacement also. So work is done. Yes, definitely work is done. So a donkey is carrying a load on its back. When a donkey will carry a load, then there will not be work by the donkey, but by the person who is taking that donkey. Okay, because donkey is moving in the forward direction. Donkey is not doing any work, remember, but the person is doing. Okay, so not by donkey, not by donkey, but by the person. Owner, you can say. Okay, anyone who is the owner of that. A windmill is filling water from a well. Water is filling by the windmill. So how it will be go? It will go in the upward direction. Here is the force and the direction. Displacement, both are in the same direction. So here, yes, the work is done. A green plant is carrying out photosynthesis. So according to the mechanical phenomena, according to physics, there is no work, but chemical phenomena, we can say there is work, but according to physics, there is no work. An engine is pulling a train. Yes, engine is pulling and train is also moving in the forward direction. Food grains are getting dried in the sun. No, there's no work done according to physics. A sailboat is moving due to wind energy. See, any kind of energy is this. Wind energy, not any person is doing work. If the boat is moving by herself due to the wind energy, but that is moving now, and force is also applied by wind. So yes, there is work. Okay, so these are some concepts. I hope now this concept is clear to you. Now our next topic is energy. Now we will discuss what energy is. So energy is nothing but the ability to do work. Energy is the ability to do work. Okay, and its unit is also same. Its unit is same because it is the ability to do work depends basically, like work depends on energy. So unit is joule. Okay. Now, is it a scalar or vector quantity? So yes, it is a scalar quantity. Okay. Now we do have many kinds of energy, but in our syllabus of 9th grade, we will discuss maximum about 2 kinds, which is kinetic energy. Okay. And potential energy. Potential and kinetic energy. Okay. But we do have many kinds of energy as chemical energy, mechanical energy, muscular energy, nuclear energy, and electrical energy. Okay, so now we are moving on our next topic, which is kinetic energy. What kinetic energy is. So, what is kinetic energy? Kinetic energy basically is the product of mass and the square of velocity. Means if there is any so kinetic energy is the energy possessed due to a moving object. Okay. So what formula will be? Its formula will be half m into v square. Okay. Energy because of the moving object, or we can say the definition, kinetic energy is the energy possessed by an object due to its motion. Okay. Kinetic energy is the energy possessed by an object due to its motion. Okay. So what is the formula? We have half mv square, where m is what? Mass, and v is what? Square of the velocity, means v is what? Velocity. Okay. Now, kinetic energy is equal to half mv square. This is our formula for kinetic energy. Now, for this also, we will be having some examples, you can say, like a moving car, okay, a flowing river, and a thrown ball. There is also energy. We'll solve some numericals related to this concept also. Okay. Now we have this question. So what they're asking, a body of mass 2 kg is moving with a speed of 20 meter per second. Find its kinetic energy. So they are asking kinetic energy. Okay. And mass is given 2 kg. Sometimes in some books, you will get it written like this, energy, kinetic. So don't get confused if I am writing like this. Mass is equal to 2 kg and speed, they have written speed, but we'll consider it as velocity only, 20 meter per second. Okay, now we know the formula of kinetic energy. What it is? I'll write like this only so that you will not be confused. Half mv square. So half into mass is given 2 kg and velocity is square. Square of 20 will be 400, right? And the unit is joule. It means kinetic energy will be 400 joule. Now we'll discuss about the potential energy. Okay, what potential energy is. So kinetic energy is because of the motion of an object. But potential energy is opposite of that, you know. What potential energy is? It is because of the state of an object. Okay. So potential energy, you can note down the definition. It is the energy possessed by an object due to its position. Okay? Or the configuration, you can say. It is because of its position. So before we have learned formula for kinetic energy, half mv square. Here the formula will be mgh. mgh, mass into gravitational acceleration. You must have introduced with this g in the previous chapter. Okay? And h is what? Height. Can we derive this formula? Obviously, see from where this formula generated. We know work is equal to force into displacement. We know energy is equal to work or work is equal to energy. So we can say like work is equal to energy or energy is equal to work. So energy is equal to force into displacement. So here displacement is in perpendicular direction. So we can take S as H, right? So E will be is equal to force into H, height. And we know from Newton's second law. What we know from Newton's second law? Did you remember? Force is equal to mass into acceleration. And here the object is not moving in the vertical direction. That's why we have taken H, right? H as a height. So here the force is applied in the vertical direction. That's why this G will convert into, sorry, A will convert into G. So F will be is equal to what? M into G. So energy is equal to M into G. And now H is here. You got this formula? Very simple, right? I hope you got this potential energy. Okay. So here also we can say some numericals and some examples. First we'll say some examples like if you have placed your laptop on your table. So laptop is having potential energy. I am having this stylus in my hand. This is having potential energy. Okay. If I leave like this, then here will be the kinetic energy. So to increase potential energy, you're doing something, right? If you want to throw a ball or if you want to do like we are saying tir and command like this, if you want to use that also, okay. So what you will do, you will stretch the thread in that thread of the bow, okay. In the archery game, in the game of archery, you will stretch the rope in that bow. If you stretch more and more, then your bow will go more fast in the forward direction. So that you are just collecting the potential energy, right? If a bowler throw a ball, then they are putting their hand in the backward direction. Why? To increase the potential energy, you can say. So that is a little bit related to momentum, we can say. Okay. So potential energy is what? Energy possessed due to the position of any object. Okay. Water is stored in a dam. That is also an example of potential energy. I stressed river. That is related to bow, like the archery game only. I hope you must have got it. Now we will discuss any numericals also related to this topic. So look at the question. A hammer of mass 1 kg falls freely from a height of 2 meter. Calculate its potential energy. What they have given? They have given mass, which is 1 kg, and height is 2 meter. And what we need to find out? Potential energy. And it is falling freely, falls freely from a height, right? It means G will be the normal value which we were taking. What is the value of G? 9.8 meter per second square, right? Now, what potential energy is? Potential energy is equal to mgh. And we will put all these values. Mass 1 kg into G 9.8 into height, which is 2. So the potential energy will be approximately 19.6 joules. So what we have got till now? We got to know about work. Work is what? Work is the product of force into displacement in the direction of force. What is energy? Energy is the ability to do work. And we have discussed mainly two types of energy, which is kinetic energy and potential energy. What kinetic energy is? Kinetic energy is the energy possessed due to the movement of any object. Okay. And formula also we have discussed. Kinetic energy is equal to half mv square. What potential energy? Potential energy is nothing, but it is just because of the position of any object. Okay. So what is the formula of potential energy? It is mgh. Now we'll move on our next topic. The next topic is law of conservation of energy. So according to law of conservation of energy, energy can neither be created nor destroyed. It can only be transformed from one form to another. Okay? Okay. So we can discuss it with a very simple example. Like you do have one object at a height and it is falling from here. So here it will be having kinetic energy 0, but potential energy maximum. As it will go down, here kinetic energy will increase gradually, but potential energy will decrease. Okay, got it? But the addition, the sum, the total energy, we can say total energy, which is addition of kinetic energy and potential energy, it will remain same. At the base here, the kinetic energy, it will be maximum, but potential energy will be 0. Potential energy will be what? 0, but kinetic energy will be maximum. Okay? But the addition, total energy, we can say, it will remain constant. Okay? Got it? You can note it down also. What will happen for a falling object? Potential energy is converted into kinetic energy. Or when a hydroelectric power plant, what will happen there? Potential energy of water, that is totally converted into electrical energy. Power plant, you must have aware of this. Okay. So I hope this concept is clear to you. If you have any doubt, then please feel free to ask any query. Please do comment, or you can ask me with the help of chat also. Thank you so much. Thanks for giving me this opportunity.